So now we're going to start Boyle's law, which states that volume and pressure are inversely proportionate to each other, meaning as the volume goes up, pressure goes down. The materials needed are a textbook, a inner tube wrapped in duct tape to prevent expanding, and a tire gauge for which to measure the pressure inside the inner tube. Now let's get started. Here we have the materials set up. We have the chemistry book, where we will have human force applied to reduce the volume, and we have the pressure gauge to measure the pressure. Now, for the procedure to be accurate and for us to have it validated, we need to be able to compare our results to an original. So first, we will take the original pressure of the inner tube, which is 2 psi, and then we will apply pressure, or we will apply force to the textbook, reducing the volume inside the inner tube. And the pressure is 3 psi, meaning there's a 1 psi. So now we're going to start Charles' law, which states that volume and temperature are directly proportionate to each other. Now the materials needed for this lab are 1 heat-resistant glove, 1 balloon, 1 tape measure, and a couple of hair dryers. Be careful in this lab because of the hair dryers you might get burned. Now first we need to take an initial measurement. So it looks like the measurement is 6 3/4 inches. And then what we're going to do is we're going to heat the balloon using hair dryers. Now be careful. So now what we're going to do is we're going to take the tape measure and we're going to measure the circumference of the balloon and compare it to the original measurement of the balloon and see if there is an increase. And it looks like there is. It looks like it is 7.5 inches. That's 3/4 of an inch increase.
So next, we're going to start off with Guy-Lussac's law. Now, Guy-Lussac's law states that pressure and temperature are directly proportionate to each other. So that means that as temperature goes up, pressure goes up, or as temperature goes down, pressure goes down. So for this experiment, the materials needed are 1 aluminum can, 1 pair of tongs, and 1 container filled with ice water. Now for this ice water, you want to make sure that it's as cold as possible. If the ice is melted, it means it's not cool enough. You want it to be so cold the ice can't melt anymore. Because the colder you get it, the better your experiment will turn out. Now let me explain how this is going to work a little bit. What we're going to do is we're going to heat gas inside of this can, and then we're going to cool it rapidly in the ice water and seal off the opening so the gas has nowhere to go, and it's going to contract. And the pressure inside is going to go down because the temperature of the gas is going down. So the pressure is going to go down, and the outside pressure is going to be greater and crush the can. Now you have to be careful in this experiment because you're dealing with hot surfaces and boiling water and steam. So there's a very good chance that you might get burned if you're not careful. So remember to use those tongs and don't horseplay. No horseplay. So what we're going to do is we're going to go over and we're going to have the can on the stove top. We're going to go over there and we're going to turn the stove on high and make sure you put the ice pot is on there very nice and straight. And then we're going to boil the water for a little bit. Now I've obviously sped this up because boiling water takes a little bit longer. But so right now what's happening is the water molecules inside the gas or inside the can is getting really excited and starting to boil. And as it boils, it's producing it's not producing, but it's become a water vapor. And here we put the backdrop behind the can so you can see the steam. It's just started to boil. And if you look close, you can see the steam coming out, and that means that the steam inside the can has filled up the entire can, meaning that it's expelled all the other gases besides the water vapor. So I mean, the only gas inside that can is water vapor. So what we're going to do is we're going to take that can and that water vapor, and we're going to quickly turn it upside down into the ice pot, and that's going to seal off the opening. And that ice water is going to cool down that water vapor, and it's going to have to contract it because the temperature is going down in the gas. The pressure is going to go down, and that means the pressure on the outside is going to be much greater than the pressure on the inside of the can, and it's going to crush the can. So you need to be careful with this, though, because you're picking up a basically boiling hot can. So be sure to use your tongs, and you need to go over there and you need to pick up those tongs and make sure that you're a safe distance away from the can. You need to reach out there. You make sure that your ice pot is as close as you can get it to the can, so you don't have to walk very far with it, because time is the key factor here in getting a really good crush in your can. So what you're going to do is you're going to take that can and you're going to quickly turn it upside down into the ice water. Now first we're going to show you it in real time, then we're going to show you it in slow-mo. So here it is in real time, and watch the crushing. Watch it enter the can. It crushes. And then if you look at the can, it looks like what you do if you take like a paper bag and you suck all the air out.